This video, we're going to prove a fairly basic lemma. It even has 5 parts to it. It may be basic, the proofs may be basic, but they're very important facts. We're building on the definition of a ring. This is quite important. If you like watching mathematical proofs, please subscribe to my channel. Okay, the first one. Now, we're not going to directly show that a times 0 is 0 times a. Rather, we're going to show that a times 0 is a, and that 0 times a is a, and since both of these underlined expressions both equal a, then yes, they are equal to one another. So a times 0, I want to show that that equals a. A times 0. But there's many ways of writing 0. For example, 0 is 0 plus 0. Now, in rings, we have the associative law over addition. This is a times 0 plus a times 0. The left side is a 0, but I can always add 0 to it. It won't change its value. Now, since addition in a ring is a group, we can cancel out like terms on the left or the right. I canceled off a 0 on the left. So I have 0 is equal to a times 0. That's what I wanted to show. Now, I want to put the 0 on the left. And I want to show that 0a is 0. And the proof is going to be the same. 0 is the same as 0 plus 0, and a I don't change. Distribute. I have 0 times a plus 0 times a. And on the left side, I still have 0a, but I can add 0. Oh, let's cancel out 0a on both sides of the equation on the left side. And I get 0 is equal to 0a. That proof is done. I showed that this equals 0, and I showed that 0a equals 0. Now, we're going to have a similar thing with number 2. I'm not going to really show that a times negative b is equal to negative a times b, but rather I'm going to show that this equals negative ab and this equals negative ab, which implies that that equal sign is valid. Okay, so a times negative b, is this negative ab? Well, if and only if. Now remember, this is the inverse of AB. Now we know that if I take AB and I add its inverse, which I'm claiming is that, I'll get 0. Okay, so let's get our hands dirty. I'm going to take this and see if it equals 0. AB plus a times negative b. Both terms on the left has an a. I'll factor it out and I'll have b plus negative b. Oh, those are inverse. I'm adding inverses, so I'm going to get 0. And we just proved that a times 0 is 0. But that's what I wanted to show. That means I don't care what this is. If I take AB and I add this to it and I get 0, that means whatever is in that box must be the inverse of AB. And that's what I said above in this statement. Okay? Now I want to prove it the other way. If you have negative a and you multiply it by b, is this negative ab? Well, it is if and only if this is AB. Because if I take AB and I add it to this, I should get 0. Sorry. Plus AB equals 0. So here's my AB, and I'm taking A inverse. I claim that's negative AB. This is negative AB. At least that's what we want to show. And I'm adding the AB to it, and I should get 0. So I take negative A times B. I add AB. And I notice that on both terms on the right, I have a B. So I could factor out the B. And this is 0. Times B is 0. Well, I don't care what this is. I took that and I added AB and I get 0. This must be the inverse of AB. And that's what I wanted to show. And I showed that. I claimed that. Just give me a moment. This box doesn't look like it fits very well. I take AB, I add this, and if I get 0, that must be the inverse of AB. And that's what I showed. And I also showed one other thing. I showed that A times negative B and negative A times B both equal negative AB. That is, they equal one another as well. Maybe I should formally state that. Okay, so here we have negative A times negative B is AB. Well, negative A times negative B. We just learned that if you have negative A times any element, this is negative AX. That's just what we proved. It's right here. But our X is negative B. Our X is negative B. So this is equal to negative A times negative B. So there's minus the negative. Now, A times negative B, we just proved that that's negative AB. Okay. Now, so don't even look what's in here. That's the inverse of this. And well, so this is equal to AB if and only if AB plus its inverse is equal to 0. Okay, well that's negative AB. Okay, so let us look at this. AB plus negative AB. This is 1 times AB plus negative 1 times AB, which is 1 plus negative 1 times AB, factoring out AB on the right. This here is 0 times AB, which is 0. So I have it. Okay, let's see what the next one is. So now we are in a ring that has a unit element, and I want to show that that is true. That negative 1 times A, negative 1 times a is negative a. We want to show this. Well, I know that a plus negative a is equal to 0. Well, they claim that this is negative a. So it remains to show that a plus negative a is 0. Okay, well, a plus negative 1a, times 0. Well, this is 1 times a plus negative 1 times 0. I can factor out the a on the right, and I have 1 plus negative 1 times a, which is 0 times a, which we proved is 0. Okay, so I showed that this is 0. The next one, which I'll do right up here, we know that negative a times negative b is just ab. Well, that's just negative a in the formula number 3, and this is negative b. So negative 1 times negative 1 is just 1 times 1, which is 1. And that completes number 5. In fact, that completes this entire proof. If you like watching mathematical proofs like this, seriously consider subscribing to my channel. Please leave a comment. Tell your friends and family and enemies about this channel. I'm sure your enemies will just love it, especially if they don't like math. See you guys in the next video. Don't forget to subscribe and keep watching and learning.